students. So as we were there, we are continuing from there. Okay, so x cube upon x4 plus 3x square plus 2. So how can we solve that? Now we need to remove x cube also. So can we take x square as t? Okay, then x4 will be t square, x4 will be t square, and x cube and 2x dx would be dt. Okay, so this is done. 2x dx will be dt, and then we would put the value, and we can move to registration. It would be x dx is equal to dt. So x dx is dt. We are left with x square. So we would write x square is t. So we can write t dt, and half is remaining at the constant side, and for the constant side we like this half integration. Okay, so like this integration upon, now our x4 is t square plus 3t plus 2. Okay, now this would be a splitting middle term question. This is a splitting middle term question, and we can solve it by 3t square plus 3t plus 2 would be t plus 1 into t plus 2, and as we can do that, the product should be 2 and the sum should be 3, so 2 and 1, so directly t plus 1 and t plus 2, and then we are done. A upon t plus 1 upon plus b upon t plus 2. Okay, so this was a simple method that I told you. Now this was a simple method, and now what we call this method is called partial fractions. And what this partial fraction says is that if it is a fraction, like we are able to see it is a t upon t square plus 3t plus 2, so it is a normal partial fraction question. So how can we solve that? So to solve this, what we would do, we would first split the middle term of the denominator, or we should factor, in simple words, we should factorize the denominator, and whatever we get, we would write like a upon t plus 1 plus b upon t plus 2, and when it is like t plus t square plus 2 square, like t plus t square plus 4, then I would write b x plus c, because it is t square, the variable is squared, so we would write bx plus c. Okay, so that would be added in the further questions. You would get like that questions also, so not here. Okay, so find dx upon 2 sine square x plus 5 cos square x. Okay, so if it is there are many methods. In the further questions you would know, and here what I say is, when sine and cos both are squared, meaning that in the denominator it is not in the denominator but in the question, if sine and cos are in squares, not in sine x cos x, it is sine square x and cos square x, then what can we do is we can convert, meaning that convert to tan square x and sec square x. By how? We can directly divide by cos square x, and if we are dividing by cos square x, what do we get? You would like get cos square x, 1 upon cos square x is sec square x dx upon 2 tan square x, sin square x upon cos square x would be 2 tan square x, and then we are dividing by cos square x, so 2 tan square x plus 5. This is that we are first dividing by cos square x to get it in the form of sec square x and tan square x. Now if we are letting that tan x is equals to t, okay, then tan x equal to t. Okay, then what would be, then sec square x would be equal to what would be equal to t dt, and with sec square x we should write dx. Also sec square x, then it would be sec square x dx equal to dt, and here in numerator it is sec square x dx only, so we can directly write dt, and 2 tan square x can be written as upon 2t square plus 5. Okay, like this. And now we should think, we 2t square would get root 2t, so can, in the first only, can we take like this and write 5 upon 2 and like this? So to remove the fractions and rotunders, as I am avoiding rotunders here, so I should avoid it at most. So 2 into t square, and I would make this 2 as constant. It would be constant, treated as constant. Okay, 1 upon 2, that would be treated as. So we are getting t square plus I upon 2. So that would be of the formula of tan inverse x and tan inverse x, and the answer would come. What does the formula of tan inverse x say that I am now telling you? Now the formula of tan inverse x says that like this, it is coming in the form of x square plus a square. Okay, x square plus a square. It is now where x is now here, it is in the form of t. That's the same thing, t square plus a square, and the root we can write 5 upon 2 as root 5 upon 2 the whole square. And now how can we write this? The formula says us that 1 upon 2 is as constant. Before only it was as constant here. Okay, here it was constant only. 1 upon 2 is far from question. Now what is the formula saying? The formula says that it would be 1 upon a, meaning that it is 1 upon a tan inverse x upon a. Okay, this is the formula says. So now 1 upon a would be root 5 upon root 5 and into root 2, and then it would be tan inverse brackets, we would write t upon what? T upon a. So a is our root 5 upon root 2. Okay, that's the same simple thing, and that's what we do. Okay, this was a simple thing that I told you. And now in these questions we should remember that if sine square x and cos square x are squared, then only we can do this these types of questions like this, or else there are different things that we do if the power of sine and cos change. Okay, that's different topic, and we will talk in later classes. As the questions come, we will talk about that also. Okay, so now moving further, we are getting also one more question. So integration. Now, are you able to see some numbers above and below integration? Now this question is definite integration. Definite integration can be done by two methods, as the limits of sums, or the second method says that it would be fb minus fa. So I will tell you that later as the question comes. And here I is saying as the limit of sums, so I will do like in the form of limit as sums. Okay, so here the question is saying a equals to minus 1 and b equals to 2. So we have to first think that what we are doing and what we have to do. Okay, so what we have to do is the limit of sums. So it is about limits, as we have done in the previous class. We have done limits. Limit is that there is something limit for everything. There is limit. Oh, that's limits. Now we are here in the topic. So here it is from integration, it is always from a to b. So here a is minus 1 and b is 2. Okay, so a is minus 1 and b is 2. Now what the question is saying is that how can we express this as the limit of sums? Okay, so what we write is integration like this, and limit h, always h tends to 0. Okay, now what h into brackets. Now you can write f from minus 1, then minus 1 plus h minus 1 plus 2h, minus 1 plus h minus 1 plus 2h till how much? Till n minus 1, n times. Okay, n times you can take. Okay, so this is done. Now we have to solve this equation. Now what can we do? First we will calculate what is f minus 1 by putting that value. If you are putting minus 1 as the value of value of x in the equation 7x minus 5, you would get as minus 7 minus 5, that is minus 12. So f minus 1 would be minus 12, and then you can calculate minus 1 plus h. Then you can calculate minus 1 plus n minus 1 into h. How? You are able to see here clearly. If minus 1, it is this. Now h, we would put the value of x as h minus 1. If we are putting here the value of h minus 1, then it would be 7 into h minus 1 minus 5, and that would be minus 7 minus 1 minus 12. So h minus 12, 7h minus 12. Okay, so as we are getting here also. And now moving further, it is then we calculate minus 1 plus n minus 1 h, as there are n terms, and so we take minus 1 plus n minus 1 raised to the power into h. Now if it is n minus 1 into h, we would put the value of x as n minus 1 and n minus h. So how can we put this value? I am now showing you here. So we can simply put this value, nothing great to do here. As we, how can we put the value is simple. First we have to think about that. So for thinking, we are putting the value of x as what? We are putting the value of x as nh minus h minus 1. Okay, so this we are putting the value of x. Now 7 into nh minus h, okay, minus 1. This is the value that we are putting, and minus 5 as outer. So always we get minus 12. The minus 12 is always there. Okay, you can see minus 12. And what is here? Here it says it is what is our n? N is n only. So n is n only. We are getting that it would be 7h taken as common. It would be left as n minus 1. We are taking h as common here. Okay, so h would be common in these two terms. So 7h into n minus 1 minus 12. As we are able to also see here. You can write this as 7n minus 7 into h minus 12. So this is the starting. And now what we do, move further. Now we have to solve this equation that we have made here. Okay, so how can we solve this equation? That now it's our main topic, that limits of, we see this method as limits of sums. Okay, so in integration, it's in the indefinite integration, you can do it by partial fraction that I told you. Then it's normal, that dt is that we take some value of x as this, and then we why we say tdt, as we take fx equals to t, then we get the differentiation dfx by dx equals to dt, and then we convert everything to dt. Okay, that's about what is that. Now here what we are doing, limits of sums in definite integration, because definite integration we can do first is by definite integration, and last we can write fb minus fa by solving it. Okay, second method, limits of sums, is something different, and mostly people ask this question. Okay, so moving further, what we can do is, okay, limit h tends to 0, and now we are getting minus 12. Minus 12 is always minus 12. For how many terms? For n terms. For n terms, so we can directly write minus 12n. Okay, so now for h, now we have to think for h. For h we are getting 7h, then 14h, then 14h, then 21h, like this, and then can we take 7h as common? Yes, we can take 7h as common. Now if we are taking 7h as common, what we are left with? We are left with 1, then 2, plus 2, plus 3, plus 4, plus 4, plus 5, plus 6. So by mathematical induction, we know that how can we add till n. It is because I here write it is n terms, and I here write n minus 1 terms. Why? Because in the first term there is no h. H is 0, meaning that it is 0h. Okay, so what now I want to write is very simple. Then I know 1 plus 2 plus 3 plus 4 plus 5. There's a simple formula for that. That is n into n minus 1 upon 2. And that now we would write limit h tends to 0. Okay, limit h tends to 0. Limit h tends to 0. Yes. Now we can write in brackets 7h. As we know, we had taken common, and now it was 1 plus 2 plus 3 plus 4. And now we can write that as n into n minus 1 upon 2. Now can you think that the formula was n into n plus 1 upon 2, and I wrote n into n minus 1 upon 2 because in that formula it was still n terms, but I am here calculating for only n minus 1 terms, because in the first term it was 0h. Okay, so because of that we got n into n minus 1 terms, n into n minus 1 upon 2. Okay, so minus 12n that we had got, like it was 12 and it was still n times, so minus 12n. Okay, now we would solve, and we know that there was an h before these brackets. There was an h before these brackets as I was writing, and now we have solved it. Now we are just going to multiply n, h, hn, hn, and we should know that what is the value of hn. Okay, so how can we calculate the value of hn? We should first look in the equation, then only we can calculate the value of nh. That is how we would convert. Now nh, as you are able to see here, the question says minus 1 to 2. So h, what h is b minus a upon n. Oh, that is. So if we write nh, what would be nh? nh would be b minus a. And what is b minus a? We have the value of b and a. B is 2.